Assalamu alaikum everyone. I am Nazia Ahmed Nijhum. Welcome to a journey into the heart of our exploration, machine learning techniques for fake news detection. Today, we unravel the details of navigating the sea of information employing knife bias classifiers and LSTM networks. Together, we embark on a journey to distinguish truth from deception in the ever evolving landscape of digital information. The outlines are literature review, knife bias classifier, LSTM network, methodology, rigorous evolution, result analysis, limitation, and future work. So let's dive into it. In the realm of today's media driven world, detecting fake news is not just a technological endeavor, it's a societal imperative. The impact of false information on public opinion, decision making processes, and societal unity cannot be understated. Our mission is clear to uphold the authenticity of public discourse and empower individuals to make well informed decisions. Join us as we explore the significance of our chosen techniques, knife bias and LSTM, in this crucial endeavor. Before we immerse ourselves in the results, let's take a moment to acknowledge uh, the rich fabric of existing research, language independent detection, NLP techniques in various languages, bias detection strategies, and the dynamic landscape of machine learning applications all lay the groundwork for our contributions to the ever evolving field of fake news detection. The groundwork of any formidable initiative lies in data pre processing. In this phase, we meticulously label, clean, and pre processes our data. These steps are the building blocks for supervised learning, ensuring our datasets are not just diverse but representative of the challenges posed by the digital information landscape. Join us as we shape raw data into a canvas feed for the intricate brush strokes of our models. Thank you. That's from my side.
Thank you, Nazia. I'm Boktiar, and I will continue the presentation from here. One of the key pillars of our approach is the use of naive Bayes classifiers. These classifiers are chosen for their interpretability, simplicity, and efficiency in processing textual data. The naive assumption they make while simplifying calculations allow them to perform well in high-dimensional spaces and large datasets. In addition to naive bias, we explore the power of long short-term memory network, a type of deep learning architecture. LSTMs excel in capturing long-term dependencies in sequential data, making them well-suited for the nuanced language found in news articles. We carefully compare the performance of naive Bayes and LSTM models, considering the factors such as accuracy, interpretability, and computational needs. Moving on to the methodology. Our methodology is a comprehensive approach that incorporates machine learning techniques and the bias theorem to discern false news from legitimate sources. The process initiates with exhaustive data collection, investigation, cleaning, and transformation, ensuring the dataset's integrity and relevance. The subsequent phases involve the intricate training and assessment of a multinomial naive Bayes model, encompassing pipeline setup, train test split, and diverse evaluation stages. Moreover, we extend our exploration to incorporate LSTM models, a type of deep learning architecture designed to effectively handle sequential data like news articles. This advanced model is subjected to a rigorous training regimen, followed by validation, and its performance truly assessed using key metrics such as accuracy and loss. This dual method enhances the model's capability to detect false news. Moving forward, counter-vectorizer, the TF-IDF, paved the way for the training of a multinomial naive Bayes model, while simultaneously the realm of deep learning unfurls with the implementation of LSTM. This dual approach, blending classical efficiency with the prowess of deep learning, defines the core of our strategy. Moving on to the results, let's begin with the naive Bayes model. In terms of testing performance, the naive Bayes model consistently achieved an impressive accuracy of 97% on the testing set. The model exhibited strong reliability in distinguishing between genuine and fraud news stories. Notably, the simplicity proved advantageous, making it easier to comprehend and computationally more cost effective. Given the balanced class distribution of the dataset, the naive Bayes model performed admirably. Turning our attention to the LSTM model, a deep learning architecture capable of capturing sequential dependencies, we observed remarkable training performance. On the testing set, turning our attention to the LSTM model, a deep learning architecture capable of capturing sequential dependencies, we observed remarkable training performance. On the testing set, the LSTM model demonstrated robust accuracy at around 97%. Despite a relatively higher testing loss compared to the training loss, the model showcased its ability to generalize the new data within the acceptable range. These results suggest that both models exhibit strengths and trade-offs, and our analysis provides valuable insight into their stability for real-world applications.
Thank you so much, Buktir, for giving me the floor. Hello everyone, my name is Mohammad Tanzil Hussain. I am continuing from the part limitations and future work. So, while our approach shows promise, it's crucial to acknowledge certain limitations like language specific constraints. Nuance in specific languages may affect the model, particularly in less represented languages. Secondly, biased training data. The quality of training data influences accuracy. Any bias may hinder the model's ability to identify false information. Scalability issues. Techniques like TF, IDF, and bag of words may pose challenges with scalability, especially with large datasets or changing language trends. Lastly, interpretability trade-offs. Striking a balance between interpretability and complex models remains a challenge impacting real-world applicability. Now, future work. In advancing fake news detection, we propose key areas for future work. Multidisciplinary adoption. Enhance the model's effectiveness across more languages, addressing challenges in less represented languages. Secondly, bias risk reduction. Implement tactics to mitigate bias in training data, ensuring a more balanced dataset. Thirdly, strategies for scalability. It's basically explore scalable methods for handling larger datasets, potentially incorporating cloud computing. Lastly, improved interpretability, exploring techniques for making complex models more understandable, fostering transparency in decision making. These directions aim to refine and expand the capabilities of fake news detection system. Thank you for your attention.
In the realm of fake news detection, our approach combines the power of naive Bayes and LSTM models. Through the application of Bayes' theorem and molecular data processing using bag of words and TF-IDF, we have achieved a remarkable boost in accuracy. Rigorous validation of multinomial naive Bayes and LSTM models ensure their reliability. Our literature review provides critical insights emphasizing adaptability. Every aspect of our model underwent scrutiny, ensuring robust performance. In conclusion, our contributions have advanced the false news identification methods, marking a significant stride in the fight against misinformation. And finally, a heartfelt thank you to our audience for staying with us on this journey. Your interest and support fuel our commitment to advancing the fight against misinformation. Thank you for being a part of this important endeavor.